Hello, my name is Jacob Thompson, and we're going to be looking at conducting correlational tests. Our agenda for this presentation, we're going to go over some assumptions and warnings. We'll look at the different correlational tests as they relate to our data set. We'll go through some main takeaways and then answer any questions that we might have. So let's go over some assumptions and some warnings before we get into our correlation tests. Remember that when we conduct correlation tests, we are doing a hypothesis test. And when we do a hypothesis test, we have to test a null and an alternative hypothesis. So our null hypothesis in this case is going to be there is no correlation between the two variables that we're looking at, or r equals 0 in that case. Our alternative hypothesis is there is a correlation between two variables, and this is a two-tailed test, so this could be a positive or a negative correlation, or in other words, r will not be equal to 0. Our alpha in this case we 0.05, and thus our rejection rule, we will reject the null hypothesis when p is less than our alpha. Some warnings here. We need to be careful with the data set that we've downloaded from the site. In my case, I could not get the data set to import into the software in order to run these tests. There was seemingly a rogue character somewhere on the spreadsheet, so I had to delete several columns and rows away from the actual data and save that in order to get it to import correctly. So be careful with that. And when running our tests, in between tests, we need to be careful that we clear the variables and then insert the new variables we're looking at before conducting these tests. So let's look at our first test. All of our tests are on a set of data related to personal finance. Not all of the variables in this data set were tested, and as a note, I have included a scatter plot for each test as a visual means of verifying and validating the data. So when we look at this first test, we're looking at income versus debt. We can see that our null hypothesis, there will be no correlation between these two variables, and our alternative hypothesis, there will be a correlation. Again, assuming that alpha of 0.05, we determined with this test that there is no significant correlation. So our p value was actually much higher than our alpha. So in this case, we have failed to reject the null hypothesis, and in this case, there is no correlation between income and debt. Our second test is related to income versus savings. So we're saying in our null hypothesis that there is no correlation between income and savings, and our alternative hypothesis is there will be a correlation between income and savings. And as you can see in the scatter plot, there is obviously a correlation between income and savings, and in this case, our p was 0, and our correlation r of 0.91 is approaching a perfect correlation. So in this case, we do reject the null hypothesis and conclude that there was a correlation between income and savings. On our third hypothesis, we looked at income versus stocks. So again, our null hypothesis would read there is no correlation between income, a person's income, and stocks that they own. An alternative would be there is a correlation. In our case, a correlation was identified. It's a weak correlation, 0.19. however, is a correlation nonetheless. If you do draw a line, you can see a weak line in our scatter plot there. A weak correlation, but a correlation nonetheless, and maybe one that would require further sampling. On our fourth test, we looked at income, a person's income, versus how much money they might have in a wallet or a purse. And in this case, you can see it's a perfect correlation. So our R was 1 with a P of 0. This was a perfect correlation, a 1-to-1 correlation of income versus the amount of money someone might carry. Our fifth test, we looked at a person's debt versus their savings. So our null hypothesis here would be there is no correlation between debt and savings. In the alternative hypothesis, there is a correlation. In this case, no significant correlation emerged. You can see that on the scatter plot. The X's and Y's are all over the scatter plot. So we failed to reject the null hypothesis, and in this case have determined there is no correlation between debt and savings. Our sixth test, we looked at debt versus stocks. And once again, we've determined that there is no significant correlation. And you can see that from the scatter plot. So our seventh test is debt versus how much money a person carries in their wallet or purse. So in this test, our null hypothesis would read there is no correlation between debt and the amount of money a person carries in their wallet or purse, where our alternative hypothesis would read there is a correlation between these two variables. And in this case, we have determined that there is no significant correlation. See there, our correlation R is negative 0.05, and our P was equal to 0.553, so significantly higher than our alpha of 0.05. And you can verify that with the scatter plot to the right there. Our eighth test, we looked at savings versus stocks, and in this case, a weak correlation did emerge. You can see that in the scatter plot. You could draw a line there through our points, but nonetheless, our P was less than our alpha of 0.05. So there was a correlation between savings and stock. Let's look at our ninth hypothesis test here. And this one is savings versus the amount of money someone might carry in their wallet. When we look at this test, we can see from the scatter plot an almost perfect correlation. So our R was equal to 0.91 and our P was equal to 0. So if you draw a line through those data points, we have almost a perfect correlation between an individual's savings and how much they might carry in their wallet. Our final hypothesis test, we looked at stocks, the amount of stocks someone might have and how much money they might carry in their wallet. And we looked at this, a weak correlation did emerge, 0.19 in this case, so you can draw a line through those weak data points there. And in this case, our P was less than our alpha of 0.05, so we do reject the null hypothesis in this case. However, we may want to do some more sampling to look at that in particular. So let's look at some main takeaways from our correlational testing. I think it's important to note that even though we have a number of variables in our data set, not all variables are correlated. And for that matter, some, even though they are correlated, are weakly correlated. So that's an important note here, is that not all data points are going to be correlated. This PSPP software is quite a valuable tool when you've got a correctly formatted data set and you need to run correlational analyses on several data points. This software is quite a valuable tool that provides both the output for the test and also graphical representation. And so which leads right into the next takeaway, that graphs provide quite a unique and great visual evidence of our analysis. It really drives the point home that yes, I can see either those strong or weak correlations, or in fact no correlation. And I think it's important to understand that weak correlations may need further testing just to validate that we do indeed have the right data. Well, I want to thank you and just offer up if there's any questions, feel free to let me know. Thank you.